Good morning, Tahmina Khan is here. In TKMaths is fun. In today's video, I will explain to you a question of arithmetic progression and geometric progression. It is a part of the syllabus of A-level mathematics, and from this year, it has been introduced in O-level additional mathematics as well. So question has been taken from A-level mathematics. Paper 9709 is the code, and paper is June 17, variant 1 to question 7. So before I begin, you can see on the top my website address and my blog address. Website has many offers. You can visit and find that yourself. And blog has the link of all my previously made videos. You may find them useful. So please do visit and share it with your friends. So let's begin with the question. So the question has two parts. We will solve one at a time. First part has arithmetic progression in it. It's mentioned here. The first two terms of an arithmetic progression are these. And second part is about geometric progression. So let's solve part one first. So the information given to us about arithmetic progression, that the first term is 16 and the second term is 24, because question is saying first two terms. You have to find the least number of terms in the progression so that when you add them up, the sum is more than 20,000. So before we begin the question, let's recall few formulae here. This formula, A plus D, A plus 2D, A plus 3D, this is a general progression of the arithmetic, right? So this is first term, second term, third term, fourth term, and so on. So for any particular term, it is A plus n minus 1D. And the reason is, if you see here, this is term 1, term 2, term 3, term 4. So fourth term has 3D, third term has 2D, second term has 1D. So that's why when we say nth term, which means Tn, it means A plus n minus 1D, right? This is also used for last term, this formula. And another formula which you need to recall is the sum of the first n terms. So the formula is n over 2 into 2a plus n minus 1d. So you need to recall these two formula. And now let's begin solving this question. So the first term is a, which is 16. The second term in general is a plus d is 24. So we know in arithmetic progression, the difference is common. So if we do 24 minus 16, the d is 8. So we know d also. Now question is saying the first n terms, the sum is greater than 20,000. So that's why we are saying sum of n terms. This n represents number of terms, and we don't know how many terms will give us sum more than 20,000. So here we will just write down the formula, which I have just shown you, n greater than 20,000. And then plug in the values of a and d, and we don't know, that we have to find out. So first term is 16. So in place of a, write down 16. Common difference is 8. We have just found out here. So after that, it is simple algebra. We just need to open the bracket and simplify it, right? So now I'm bringing it to this side. And now you can apply quadratic formula. You can simplify whatever way you like to solve it. If you can factorize it, you can factorize. I'm applying quadratic formula. And I got two values of n. So basically, I'm saying n is greater than 69.2 or minus 72.2. So negative value is not applicable because we're talking about number of turns. So when I say n is greater than 69.2, it means 70 terms. Do not round it off. The concept of rounding off will not be applied here. Some people think it is 69.2, so whole number will be 69. No. We are saying how many terms will give us sum more than 20,000. So if it is less than this, then it will not be. So the next term after this is 70. So at least 70 terms we have to add up to get the sum more than 20,000. So now let's solve part B. The part B is about a geometric progression, and it is saying um, first term is 6 and sum to infinity is 18. These two pieces of information, and actually it is saying you have to find a new geometric progression which is actually the square of each of the original progression. So right now we know only A, we don't know R. So we need to find out R also, because we have to find out the sum to infinity of the new progression. So we have to find out A and R of the new progression, right? Only then we can apply in the formula. So let's recall here a few formulae first. Now this is a general sequence of the geometric progression: A, AR, AR square, AR cube. So basically, if I say nth term, it is AR n minus 1. Because you see, this is first term, second term, third term, fourth term. So power of R is 1 less than the term we are talking about. So when I say nth term, it means this. So the general term will be AR n minus 1. Okay. So whatever the number will come here, the term you are talking about, this will be 1 less than that. And the reason you understand from here. Now, then you also need to recall the formula for the sum of few terms or sum of infinite terms, right? I have explained all this very much in detail in my other video. I will give the link in the description below, in which I have explained geometric progression and arithmetic progression in detail. Anyway, so for this question, you need to recall these formulae, because question is saying find the sum to infinity. So we will apply this formula and we will check this condition. Does it satisfy or not before applying this formula? So let's begin solving the question. So the first term is A and sum to infinity is 18. So of course we will apply the formula for the sum to infinity, because this is the piece of information given to us. This is the formula for sum to infinity. I will plug in A and find out the value of R. Simple calculation. I hope you understand. And then my value of R is coming 2 over 3. Now you see this value of R is in between this, right? But question is saying you have to find new geometric progression, and in that you have to square each of the term of the original progression. So my A is 6, I will square it, and R is 2 upon 3, I will square it. So for the new progression, my A is 36 and my R is 4 over 9. And because R is in between -1 and 1, hence I can find out the sum to infinity. This formula, this condition must be met if you are finding sum to infinity. The reason I have explained in my video of introduction, you can find the link below. Okay, so now I'm applying the formula for the sum of infinity, A over 1 minus R, plugging in the values and simply solving it. So this is giving me the answer for the sum to infinity, which is 64.8. So I hope you have learned something from it. Thank you very much for watching it. If you liked it, please press like and subscribe button, give your positive comments, which will be source of encouragement for me. And please do share it with your friends. Thank you. Take care. Allah Hafiz.